Hello everyone. Welcome to the video lecture series of 8086 architecture. So in today's lecture series, we are going to discuss much detail about the architecture of 8086. So now let us get into the presentation. So as shown here, the architecture of 8086 microprocessor is generally classified into two portions. One is BIU, that is bus interface unit, and EU, that is the execution unit. So as the name suggests, the bus interface unit is going to fetch and decode the instruction, while the execution unit is used to execute the instruction after the decode. So now let's get deeper into the various sections of this architecture, and the diagram represents the overall architecture of the 8086. So here, as mentioned earlier, the execution unit executes the instructions that have already been fetched by the BIU, and BIU fetches the instruction, reads the data from the memory and the input output ports, as well as writes the data to the memory and the input output ports. So the EU consists of the following parts, that is nothing but AX, BX, CX, and DX, which are all called as the general purpose registers, and they are all 16-bit registers. So AX is a complete 16-bit register, while AL and AH is 8-bit registers separately. So now, coming to the bus interface unit, you can see the segment registers, which are nothing but CS, DS, ES, SS, and IP is the offset register. So here the CS stands for the code segment, and DS stands for the data segment, and ES stands for the extra segment, and SS stands for the stack segments. So let us get deeper into the bus interface unit. The bus interface unit consists of an address generator, which is generally purposed to produce 20-bit address, because there are only four 16-bit registers which are capable of producing 16-bit address, while there is a physical formula to calculate the physical address of the address bus. That is, physical address is equal to segment register into 10H plus offset address. So with this formula, the 16-bit address will be converted into the 80-bit address, so that the data can be easily accessed, or the instruction can be easily accessed from the memory. Then comes the instruction queue, which is nothing but a 6-byte prefetch instruction queue, which is used to prefetch the instructions from the memory segment, so that there is no necessity for the execution unit to wait for the instruction. It can parallelly execute the instruction while the one is already executed. So here you can see that the 8086 registers and its abbreviations. So AX, BX, CX are nothing but the general purpose registers and are of 16-bit, as mentioned earlier, and they are called as the general purpose registers. It can be again classified as AL, AH, BL, BH, CL, CH, and DL, DH. And SP and BP are nothing but the 18-bit registers, which are nothing but the point registers. And SI and DI are again 16-bit registers, which are called as the index registers. And IP are the instruction pointer, which are nothing but the 16-bit. CS, DS, ES, and SS are, segment registers, which are again 16-bit registers. And the flag registers are 16-bit registers. And are coming to the special function registers, that is AX or AL, and BX, CX, DX, SP, BP, SI, and DE. So we'll see what are its functions. So AX is generally used to store the 16-bit results of the arithmetic and logic operations. And AL here stores the 8-bit results of the arithmetic and logic operations. So BX, which are the base registers, are used to hold base values in the base addressing mode to access the memory access data. Count registers or CX are used to hold the count value in shift, rotate, and the loop instructions. So DX, which are nothing but the data registers, are used to hold data for multiplication and division operations. And SP, which is nothing but the stack pointer, are used to hold the offset address of top stack memory, while BP, the base pointer, are used to hold the base value in the base addressing using SS registers to access the data from the stack memory. And SI, which is nothing but the source index, are used to hold the value, index value of the source or the operand data for string instructions. So now the data index or the DI is used to hold the index value of the destination operand data for the string operations. Now coming to the segment registers. So as you all can see, and before moving into the segment register deeper, let us see about the memory segmentation. Generally, the memory segments are classified into 5 segments, which is segment 0, segment 1, segment 2, segment 3, and segment 4. So the segment 0 and 1 are said to be continuous segments, and segment 1 and 2 are said to be partially overlapped, and segment 2 and 3 are said to be fully overlapped, while segment 2 and 4 are completely disjoint. So you can see that from the diagram, you can see that 8086 comprises of 1 megabyte memory, which is subdivided into segments, and each segment will consist of up to 64 kilobytes of memory. So the 8086 can directly address 4 segments at a particular time. So that is also possible using a 8086. And the programs obtain access to code and data in the segments by changing the segment register content to point to the desired segments. So now coming to the segment register. So the first one is the code segment register. So generally the code segment register is 16-bit, and this contains the base or start of the current code segment. So IP contains the distance or the offset from this address to the next instruction byte to be fetched. So BIA computes 20-bit physical address by logically shifting the contents of CS 4 bits to the left and then adding the contents to the IP. So that is, all instruction of this program are relative to the contents of CS registers multiplied by 16, and then offset is provided by the IP. So that's all for this session. Let us look into the rest of the segment registers in the forthcoming session. So before moving into the ending the session, I just want to ask a question. So how is the architecture of 8086 broadly classified, and what are its names? Thank you.